Hello everyone, this is Grishma studying engineering third sem. My subject is operating system. Subject code is BCS 303. My topic is about deadlocks in OS. About deadlocks in OS. Contents are introduction, definition, necessary condition, mutual exclusion, old and wait, no prevention, circular wait, preventions, avoidance, detection, recovery, reward scenarios, tools for analyzation, case study, future trends, and conclusion. Introduction. Deadlock is a situation in OS where two or more processes cannot be proceed because each is waiting for the others to release the resources. It is critical issue that can lead to a system being unresponsive and can impact overall performances. Understanding deadlock is essential for designing efficient and reliable operating system. Definition of deadlock. A deadlock occurs when a set of processes are blocked because each process's older resources wait for another resources held by other processes. I repeat, deadlock processes when I set up processes are blocked because each other processes older resources and wait for other resources held by another processes. This condition results in a cycle of dependence and that cannot be resolved without external intervention. Identifying deadlock condition is crucial for effective resources management in operating system. Necessary condition for deadlock. Four conditions must hold simultaneously for deadlock to occur. Mutual exclusion, hold and wait, no prevention or circular wait. I repeat, mutual exclusion, hold and wait, no prevention or circular wait. Mutual exclusion means that at least one resources must be held in non-shareable mode. Understanding these conditions helps in developing strategies to prevent further resolving deadlocks. Mutual exclusion. Mutual exclusion occurs when resources cannot be shared and is located to one of the processes of time. When the resources is held in the mutual exclusion, other processes must be wait for it to be released. Condition is fundamental in understanding how deadlock can occur in the resources allocation. Hold and wait refers to processes holding at least one resources while waiting acquiring additional resources. This situation can lead to the scenario where multi-purposes are holding resources and waiting indifferently. Preventing this condition involves ensuring that processors request all required resources at once. No prevention. No prevention indicates that the resources cannot be forcibly taken from processing holding them. In this scenario, resources can be released virtually by the process of holding it after it has completed its task. This condition make it more challenging to resolve deadlock as a processes cannot be interrupted. Circular wait. It occurs when a set of processes are waiting for each other in circular chain. Example, A waits for resources held by process B. B wait for resources held by C. Process C wait resources held by A. This condition is most critical aspects of deadlock highlight the dependency of cycle. No prevention indicates resources cannot be possibly taken. Deadlock preventions and techniques. I repeat, deadlock prevention technique aim to eliminate one or more necessary conditions for the deadlock. These techniques include ensuring mutual exclusion, eliminating hold and wait, enabling prevention, preventing circular wait. Implementing this strategy can significantly reduce the risk of deadlock occurring. Deadlock avoidance the technique. Deadlock avoidance involves dynamically deciding whether to grant resources requests based on current state of resources allocation. Excuse me. The bankers allocate well-known method that help to ensure the safest state and avoid deadlocks. This technique requires knowledge of future requests to make the decision on resolution and allocation. Deadlocks detection. Detection involves allowing deadlock to occur but having mechanism to detect them afterward. This approach is typical uses and resource allocation graph or wait for the graphs to identify cycle indicating deadlock. When detected, the system can take action to recover from deadlock in the situations. Recovery. Recovery from deadlock can be achieved through the process of termination or process of prevention. Process of termination involves killing of one or more processes to break a deadlock cycle. Resources prevention may involve forcibly taken resources from processing to resources the deadlocks. Example, consider a situation of two processors P1, P2, where P1 holds resource of A, waits for resource B, while P holds resource of B, waits resource of A. This scenario creates circular wait situation of leading a deadlock. Analyzing such examples, understanding the practical implementability of deadlock in OS. Real world scenarios deadlock can occur in various real world applications including database management system and network protocols. In database, transactions may look row, wait for other to release their looks, leading the deadlocks. Network protocols can also face deadlock with multiple resources, attempt to acquire resources simultaneously without coordination. Tools of deadlock analysis. Various tools or techniques are available for analyzing and visualizing deadlock in OS. Tools such as resource allocation, graph, deadlock detection algorithms, wealth administration, identifying and resolving deadlocks. Understanding these tools essential for system administration and developers to maintain system reliability. Case study of deadlock in OS. Future trends in deadlock management. As systems become more complex, the needs of advanced deadlock management strategies will increase. Artificial intelligence, machine learning may offer new approaches for predicting the preventing deadlocks. Continuous research and development are vital in evolving deadlocks management technique in modern operating system. Conclusion is that overall the deadlock is critical issue in OS that are several impact system performances and reliability. Understanding the condition and preventions, avoidance and recovery techniques is crucial for system designers and administration. Ongoing research and development in this area will help to more robust and effective operating system in future. This presentation covers various aspects of deadlock in OS and providing an overview and detailed explanation of concepts and insight into the management techniques. Thank you.